Welcome to Goldwyn, your educational oasis. I'm Anwar Masood, glowing star dive into a world of knowledge, inspiration, and endless possibilities. Subscribe now and join us on this exciting journey. The source of uncertainty in a thermometer refers to factors that can introduce inaccuracies or variations in temperature measurements. These factors include calibration errors, environmental conditions like temperature fluctuations, measurement techniques, and instrumental errors. Uncertainty in thermometer readings can arise from any of these sources, affecting the reliability and precision of temperature measurements.
Have you ever pondered over the significance of thermometer calibration? Well, let's dive right in and shed light on this crucial concept. Thermometer calibration, simply put, is the process of checking and adjusting the thermometer's reading to match a known temperature standard. It's like aligning your watch to the precise time, ensuring that when it points to 12, it truly is noon. Thermometer calibration plays a similar role in the world of temperature measurements. Now you may ask, why is this so important? Let's think about a world without calibrated thermometers. Imagine you're baking a cake. The recipe calls for an oven temperature of 180 degrees Celsius, but your oven's thermometer hasn't been calibrated. It reads 180, but the actual temperature might be higher or lower. The result? You end up with a burnt cake or an undercooked one. Not a big deal, you might say. It's just a cake, but let's take this to a larger scale. In the healthcare industry, thermometers are used to monitor body temperature, which is crucial in diagnosing and treating illnesses. An inaccurate reading could lead to a misdiagnosis, potentially risking a life. Similarly, in scientific research, precise measurements are fundamental. Experiments are based on specific conditions, and any deviation, however minute, could invalidate the results. The food industry is another area where thermometer calibration is vital. It ensures that food is stored and cooked at safe temperatures, preventing foodborne illnesses. Moreover, in manufacturing industries, temperature control directly affects the quality of the products. An uncalibrated thermometer could result in faulty goods, leading to substantial financial losses. So, you see, the importance of thermometer calibration extends far beyond just getting your cake right. It's about accuracy and precision, it's about safety and quality, and it's about ensuring consistency and reliability across various fields. So, if you want precise and accurate temperature readings, thermometer calibration is the way to go. And remember, an uncalibrated thermometer is like a clock that doesn't tell the right time. It's not entirely useless, but it's definitely not reliable. But did you know there are certain factors that can cause uncertainty in thermometer calibration? Indeed, the calibration process is not immune to inaccuracies. One of the primary sources of uncertainty is the quality of the thermometer itself. If the thermometer is damaged or poorly made, it can lead to inaccurate readings. Furthermore, the resolution of the thermometer, meaning the smallest change it can detect, can also affect the level of uncertainty. Environmental conditions too play a significant role in thermometer calibration uncertainty. Factors such as ambient temperature, humidity, and air pressure can influence the accuracy of a calibration. For instance, a thermometer calibrated in a cool, dry lab might not provide accurate readings in a hot, humid field environment. Human error is another significant source of uncertainty. Misreading the thermometer, misrecording data, or even mishandling the thermometer can all lead to inaccuracies. It's crucial to have well-trained personnel carrying out the calibration to minimize such errors. The calibration method used is also a fundamental source of uncertainty. Different methods may yield different results due to the inherent uncertainties in those methods. For example, comparing the thermometer to a reference standard might introduce uncertainties related to the reference standard's accuracy. Other factors include the stability of the thermometer over time. A thermometer might give accurate readings today, but what about a month or a year from now? This is where periodic recalibration comes into play. Then there's the matter of repeatability, the ability of the thermometer to give the same reading under the same conditions. If the thermometer gives different readings each time, it introduces another layer of uncertainty. Let's not forget the influence of thermal conduction, convection, and radiation. These heat transfer modes can affect the thermometer's reading and introduce uncertainties. And these are just the tip of the iceberg. There are more factors that add to the uncertainty. So as we delve deeper into the world of thermometer calibration, it's essential to be aware of these potential pitfalls and navigate them with the utmost precision. Still curious about the other sources of uncertainty in thermometer calibration? Well, let's dive right in. First up, we have temperature gradient. This refers to the difference in temperature between different points in a system. If your thermometer isn't correctly placed in the area with the temperature you're trying to measure, this could lead to inaccuracies. For instance, if you're trying to measure the temperature of a liquid, the thermometer should be placed at the center, not near the walls of the container, where the temperature might be different. Next, we have the issue of measurement resolution. This is the smallest change in temperature that a thermometer can detect. If the resolution isn't fine enough, you might not be able to detect small but significant temperature changes. It's like trying to measure the length of a feather with a ruler. The tool just isn't precise enough for the task. Moving on, we have hysteresis. This is a phenomenon where the response of a system depends not just on its current state, but also on its history. For thermometers, this means that the current reading could be influenced by previous temperature measurements. Imagine if you measured the temperature of a hot object and then a cold one. The reading for the cold object might be slightly higher than it actually is because the thermometer is still cooling down from the previous measurement. Finally, let's talk about instrument drift. Over time, the performance of a thermometer can change due to factors like aging, wear and tear, and environmental conditions. This is why it's important to regularly check and recalibrate your thermometers to ensure they're still giving accurate readings. So there you have it, 4 more sources of uncertainty in thermometer calibration: temperature gradient, measurement resolution, hysteresis, and instrument drift. Each of these factors can introduce errors into your temperature measurements, and being aware of them is the first step in mitigating their effects. Remember, these factors can significantly affect the accuracy of your thermometer readings. Let's recap what we've learned about the sources of uncertainty in thermometer calibration. First and foremost, we delved into the realm of calibration uncertainty, which arises from the inherent limitations of the calibration process itself. Whether it's due to the precision of the calibration equipment or the repeatability of the calibration process, these uncertainties can impact the final temperature readings. We then touched on the subject of environmental uncertainties. These range from fluctuations in ambient temperature to changes in humidity and air pressure. Even the slightest shift in these environmental conditions can lead to discrepancies in thermometer calibration, affecting the accuracy of your readings. Next on the list was the thermometer's inherent uncertainty. This revolves around the device's internal characteristics, such as the precision of its sensor and its inherent stability over time. If your thermometer isn't stable or its sensor isn't precise, you're bound to encounter uncertainties. We also discussed the role of human error. This can stem from incorrect reading of the thermometer or even misinterpretation of the calibration data. Remember, even the most advanced thermometer is susceptible to human mistakes. The fifth source of uncertainty we explored was related to the calibration standards. These standards, while designed to be reliable, are not completely free from uncertainty. The accuracy of these standards and how closely they are followed can directly impact the calibration process. Following that, we examined how the method of calibration can introduce uncertainty. Whether it's the technique used or the procedure followed, the method of calibration can significantly affect the accuracy of your thermometer readings. We also acknowledged that uncertainties can arise from the material of the thermometer itself. Different materials react differently to temperature changes, thereby influencing the calibration process. Lastly, we looked at how temperature gradients within the medium being measured can contribute to uncertainty. If the temperature isn't uniform throughout, it can lead to inaccurate readings. So, while thermometer calibration is crucial, it's equally important to understand and manage these sources of uncertainty. So, what should you take away from all of this information about thermometer calibration and its uncertainties? As we've journeyed through the labyrinth of thermometer calibration, it's become increasingly clear that accuracy is an art, not just a science. Every thermometer, no matter how sophisticated, is susceptible to a myriad of uncertainties that can skew its readings. From the ambient conditions in the room to the inherent characteristics of the thermometer's components, from the calibration process itself to the potential for human error, these are but a few of the many factors that can introduce uncertainty into your temperature readings. But this isn't cause for despair. Rather, it's a call to action. Regular calibration is the cornerstone of accuracy. By frequently checking and adjusting your thermometer, you can ensure that it's always as close to the true temperature as possible. Yet, calibration isn't a one-and-done deal. It's an ongoing process that requires constant vigilance. This vigilance isn't just about performing regular calibrations, but also about being aware of the potential sources of uncertainty and taking steps to manage and minimize them. You can manage these uncertainties in several ways. For instance, you can control the ambient conditions during calibration, handle your thermometer with care to minimize mechanical stress, and use calibration standards with known uncertainties. You can also invest in training for your calibration technicians to ensure they're up to date on the best practices and techniques. And of course, you can adopt quality control processes that regularly check for and address any sources of uncertainty. In the end, it all boils down to a simple truth. The key to accurate temperature readings isn't just a high-quality thermometer, but also a robust calibration process that accounts for and minimizes uncertainties. So, let's not shy away from the complexities of thermometer calibration. Instead, let's embrace them and use them to our advantage. Because it's only by understanding and managing these uncertainties that we can truly trust our thermometers to give us the accurate readings we need. Remember, the key to accurate temperature readings lies in regular calibration and effective management of uncertainty sources. So stay calibrated, stay accurate.